Assalamualaikum and good evening everyone. So we are from group 5 and in this video we will be going through several naval architecture questions that cover important topics such as hydrostatic, stability, draft changes, trim and ship form coefficient. So in this topic are fundamental in understanding how ship float, balance, respond to loading condition and interact with water around them. So each question highlight a different concept and involve real world calculation that are commonly used in marine engineering and ship design. We will explain each question step by step, show the full working for every calculation and include diagram where necessary to make the concept easier to understand. So for the first question, Nasir will go through first. Nasir, open the mic.
Okay, Nasir.
Assalamu alaikum everyone. My name is Shajar Nasser and I'm going to solve question 1. So, okay. Okay. For the question 1, guys, the screen, you can see it? Okay. For the question 1, let's read first the question. So, a vessel has a breadth of 22 meters and the draft has a 13 meter table 1. Below shows have ordinates measured at 3 meters. Vertical interface for the keel. So for the first one, for part A, show that the midship area can be calculated using Simpson's first rule only. So for to answer this question is you have to follow that Simpson first rule required the number of intervals to be even, which mean the number of ordinates is odd. So it's like the ordinates number like as shown 0 and 1, 2, 3 and 4. So 5 ordinates, which means 4 intervals. So even number of intervals. So that's mean for the answer for the part A, yes, Simpson first rule can be applied for this question. So for part B, calculate the midship sectional area. So first of all, before we solve, let's get the data first from the question. So for the breadth, which is B, it's equal to 22 meter, and the draft with unit T, with sign T, sorry, it's equal to 13 meter. So, and the half ordinates measured at 3 meter, vertical invert. So, to calculate, we use the formula, which is area equal to d over times y0 plus y4 and plus 4 times y1 plus y3 plus plus 2 times y2. So which means d, the d which we use it here, and to get the d, it's equal to the vertical spacing, which is 3 meter. And u0, as we have to follow the this one tables. So to get the y, so y0 is equal to 6 and y1 8.2, y2 9.4, y3 10.1 and y4 10.7. So let's solve by the formula. So this one we put every number behave the unit in the same formula and we calculate, and the middle of calculate we get 1 times 16.7 plus 4 times 40.3 plus 18. So the final answer will be 108.7 meters cube. Uh, so this one for B. So for C, uh, determine the mateship coefficient. So for C, calculate. So this is the formula. Cm equal to Am over B times T. So Am, we will have it also from the we will have it also from the tables, which is sorry, for the last answer we with the area. So the area 108.7, and the B and the T already given in the question, the main question. So directly we solve the formula and we get the final answer is 0.38. So for the last one, for question 1, D, define the vertical center of area from the keel. So first of all, this is the Z value. This is the Z formula we use. It's kind same the previous one, but we added all the equation over the area. It's the same totally. So, and this one is the number 0134, and for the Z, this the data, and for the Y also, and for the YM, which is, for example, Z, sorry, Y0 is equal to 6, and Y1 it's equal to 9.4. So we go directly by the formula. This is the full equation, and we calculate, and as it given the area for the previous question 108.7, and we calculate the total. So the vertical center will be Z equal to 6.47 meters. So that's for me for question 1. Now we're going to question 2.
Okay, so right now I will take over for the next question. That is question number 2. Share screen. Okay. Okay, so for question 2 is about stability with cargo loading. So a ship of 8,000 tons with kg 8.80 meter loads 1,800 tons of cargo at kg 12.50 meter. The KMT is 10.20 meter. So the kg stands for the kg stands for change based on weight and cargo position, while the km is keel to metacenter, kmt keel to transverse metacenter, and gm is metacentric height. So for the first question is to determine the final kg of the ship after loading. So in this question, given 8,000 tons for the ship original displacement. For the original kg is 8.80 meter. Cargo loaded is 1,800 tons at 12.50 meter, and KMT is 10.20 meter. So for the final kg after loading, we're gonna use this formula. So the formula is weight 1 times kg1 plus weight 2 times kg2 divided by weight 1 plus weight 2. And then we're going to insert the number given into this formula. So the answer for the question A is 9.48 meter. So for the next question is calculate the GM, and comment on the ship stability. So KM is equal to KMT 10.20 meter, and then KG is 9.48 meter. So we're gonna use this formula, that is GM equal to KM subtract to KG. And then the answer that we will get is 0.72 meter. So the ship is statically stable. GM of 0.72 meter is moderate. The ship will return upright after small tail, but large GM give better stiffness. And then for the next question is, the cargo is then shifted vertically downward by 4.5 meter. Find the new kg and GM. So the weight is 1,800 tons. The draught is 4.5 meter downward shift, and the weight number 2 is 9,800 tons. And then we're going to use this formula. We insert the formula, and then we will get the 0.826 meter. To get the new kg, 9.48 meter subtract to 0.826, and then we will get answer 8.65 meter. And the new GM, we will get the answer is 1.55 meter. And the last question is, suggest one way ballast water can be used to improve stability. We need to add ballast water to tanks at the bottom of the ship and bring the center of gravity lower so the ship becomes more stable and less likely to tip. Okay. Done. Okay. Next.
I will explain for question 3. Okay, for question 3, the question is about a barge of dimensions 35 meter length, 8 meter breadth, and 5 meter depth floats in sea water, Sg equal to 1.025. TPC at draft 3.5 meter is 14.2 T/cm. For question A, calculate the current mass displacement. So, given the current draft of 3.5 meter, the calculation for displacement volume is V equal to L times B times draft. For L is 35 meter, B is 8 meter, and draft is 3.5 meter. We will get 980 meter cube. Now, to find the mass displacement, we use the formula of V times Sg times 1000. In seawater, Sg 1.025, the density is 1025 kg per meter cube. We need to insert the volume of V equals to 980, Sg 1.025 and times 1000. We will get 1004.5 tons. For question B, if 450 tons are discharged, what will be the new draft? So let's consider what happens if 450 tons discharged from the barge. The mass removed will be 450 tons. We will need to use TPC 14.2 T/cm, and the change in draft for the formula will be mass removed divided by TPC. So 450 divided by 14.2, we will get 31.7 centimeter. We will need to change it to meter, so we will get 0.317 meter. Since the cargo is discharged, the draft will decrease. So the new draft will need to be minus. So the new draft will be 3.5 meter minus 0.317 meter. We will get 3.183 meter. For question C, the barge then takes in 750 tons of cargo. What is the final draft? So the barge takes in 750 tons. The mass added is 750 tons. The same formula will be used. 750 divided by TPC 14.2, we will get 52.8 centimeter. Convert it to meter, we will get 0.528. Since the cargo is added, the draft will increase. So we need to add the new draft. So 3.183 meter plus 0.528 meter, we will get 3.711 meter for the new draft. And for question D, what is the change in draft if the barge moves to fresh water? So when a vessel moves from denser water, seawater, to less dense water, fresh water, its draft will increase to displace the same mass. So the change in draft, we will use the change in draft due to water density, we will use the formula current draft times Sg seawater divided by Sg freshwater minus 1. Insert the current draft 3.711 times Sg seawater is 1.025 divided by Sg freshwater is 1.000 minus 1. We will get 0.093 meter. And then we will convert it to centimeter. So the draft increased by 9.3 centimeter in fresh water. To calculate the new draft, you will need to add from the previous draft. So 3.711 meter plus 0.093 meter, we will get 3.804 meter for the new draft. That is all for question 3.
Okay, next I'll be talking about the question 4. 30 meter. The question 4 is about the longitudinal trim calculation. A 130 meter long ship with light displacement of 4,500 tons with the mean draft of 7.5 meters and MCT 1 centimeter equals to 170 TM, and the longitudinal central flotation equals to 2.2 meters aft of the midship, and undergoes the following longitudinal weight shift, which is for the cargo 1, the weight is 500 tons. The initial position is 1.2 forward of the ship, and the final position is 4 meters aft of the ship. Next, the cargo 2 weights with the 2.9 tons, 2,900 tons, with the initial position of 2.8 meter aft of the ship, and the final position of 0.8 meter forward of the ship. Question A asks to determine whether the ship trims forward or aft. First, we list out all the information given, which is the length with 130 meters, the displacement of 4,500 tons, with the mean draft of 7.5 meters, and the MCT 1 centimeter equals to 170 meter aft of the midship. Question A asks for the ship trims, which is with the formula trimming moments equals to the weight times the displacement times the distance shifted. For cargo 1, the cargo shifted from 1.2 meters forward of the ship to 4 meter aft of the ship equals to 1.2 meter plus 4 meters equals to 5.2 meters aft of the ship. Next, for the movement of the cargo, the moment of the cargo, which is the weight of the cargo times with the new shifted weight of the cargo, which is 5.2. Next, as for the cargo 2, the cargo moves from 2.8 meter aft to 0.8 meter forward of the ship, equals to 2.8 meters plus 0.8 meters, and you get 3.6 meter forward of the ship. For the moment of the cargo 2, which is the weight of the cargo with 2,900 tons times with 3.6 meter, and you get 10,440 TM forward of the ship. For the net moment of the cargo, you basically just minus the cargo 1 and with the cargo 2, which is 2,600 TM after the ship minus with 10,440 TM forward of the ship, and you get 7,840 TMs forward of the ship. Next, for question B, it asks to calculate the new forward and aft of the draft. With the trim change formula, you use to trimming moments, divide with MCT 1 centimeters, and you'll get 7,840 divide with 170, and you'll get 46.12 centimeters of trim change. Next, with the draft, times with L/2, which is the length, divide with 2 plus or minus the LCF divided by the length of the ship. The trim you need to convert from centimeter to meter, and which is you just divided with 100, and you get 0.41612 meters. And for the forward draft changes, which is you take the trim with the new unit, which is 0.4612 meters times with 65 plus 2 LCF draft. And divide with 130 equals to 0.2376 meter, which is the increase in draft for the forward. And next, for the aft draft changes, also use the same formula with 0.4612 times with 6 minus 2 divide with 130, and you get 0.2234 meters with the draft decreases at the aft of the ship. And you'll get the final draft of the ship minus with the depends on the answer, the increase or decrease. You just need to minus with the initial draft. 0.2376 meters, and you get 7.74 meters. And for the aft draft, which is with 7.5 equals minus with 0.2234, and you get 7.28 meters for the final draft at the aft. And for the last question, it's stated that to illustrate one vessel's motion, reduce it, which is a vessel motion that can be reduced by hydrofoil design. Hydrofoils lift the hull at speed, decreases wave impacts, and damping pitch through hydrodynamics. Illustration stated that hydrofoil is another component that located under the ship near the keel. And that is all from me. Thank you.
hello. Continue for question 5. For question 5, the ship form coefficient. The first question is define and derive for the following with sketches. Sketch. First block coefficient. The definition is ratio of underwater volume of the ship to the volume of the enclosing rectangular block. The formula is CB, volume of displacement. LBT means the L is link between perpendicular, B is breadth, T is draft. If the coefficient CP, the definition is ratio of the underwater volume to the product of the maximum underwater cross-sectional of area and the ship length. The formula is CP, volume of displacement of the ship, waterline length, and area of the midship section. Okay, next, the waterplane area coefficient, CW, definition, ratio of the actual waterplane area to the rectangular area defined by the ship length and breadth of the waterline. Is CW, WPA, L, and B. Okay, next, for the big question is a ship replacing 9,000 tons has following. And for the first lot, 150 tons at 5.8 meter and 600 tons at 150 divided by 5.8 and 6 plus 600 divided by 3.4. The answer is 291 tons meter. Next, the discharge to the 7 tons of from 2.2 meter and 90 tons from 5.5 meter. The moment is negative 70 divided negative 90 divided by 5.5. The answer is negative 649 tons meter. Next, the ship 100 tons from 3.0 meter to 6.2 meter. For this 100 divide in the bracket 6.2 minus 3.0 equal to 320 tons meter. Okay, for the final kg after all the operation, the total moment, net moment 290. To this you sum all the moment and get 2581 tons meter. Next is initial moment. The displacement divided by the answer 45000 tons meter. Okay, the final kg is 4500 plus 2581 divided 900,000 plus 70750 minus 160. The answer is 4.962 meter. Okay, for the next question is question 6. Floating hotels with division 28 meter and 0.5 meter float at the drop 3.2 meter in the seawater CG equal to 1.025. First, calculate the displacement. First, we give the data. First part is calculate the displacement using a formula of V L divided by V divided by T. The answer is 6.2, 7.2 meters. CG, and we got 6 for 3.88 tons. Okay, next the drop for the freshwater CG. $6.3.88, and the same with the formula, we got 3.285 meter. Here for the cargo, remove to reduce the draft by 0.5 meter in seawater. The draft chain we convert to 50 cm. The TPC divided by displacement T. The answer is 6.690 tons. Okay, the last is the final draft of the loading 500 tons. Uh, 500 divided by 3138. The answer is cm, we convert to meter, and the final drop 3.2. Then we got 3.56 meter. Okay, that's all from me. Thank you.
Nasi, you can proceed for question 6.
Hey, ready.
Uh, Okay.
Yeah, efficiency research.
I think already solve it.
Nutup ah.
So that's all from us. Thank you.